BF Day proudly presents Mr. M's Math Class.
Hey everybody, and welcome to episode 11 of Mr. M's Math Class. I'm so excited that you're here. We are going to shift to some fifth grade content this week, so just be aware that it might ramp up for some of you fourth graders. So just be ready for that. But I think you'll be able to handle it, to be honest. First thing we're going to do today is we're going to look at some pictures of you guys looking at episode 10. I didn't actually get a lot of pictures. I just got 3, and 2 of them are of the same student. So please make sure to send those in. It's really, really great to see each other. And like I said, you guys are the ones saying that it's really nice to see each other. So if you like seeing everybody else, you should take a picture and then send it to me, please, for the next episode. Second thing, we have a new estimation 180, and this one was given to us by Lucille. So thank you, Lucille, for that question. 3, I'm going to tell you about the quarantine challenge question answer, and then I will reveal who are the winners for the quarantine challenge question. 4, I'm going to introduce math exploration number 11, and like I said, fifth grade content, and we're going to talk about ordered pairs and classifying quadrilaterals with a little bit of review from classifying triangles. And then 5, I'm going to introduce a new coloring mural sheet. That's a little fun today. And then I'm going to introduce the new quarantine challenge question, question number 5. And then we'll have a goodbye message and estimation 180 answer. And then I'm going to have a little bonus assignment that's a little fun and silly. So here are the 3 pictures that I got from you guys of students looking at episode 10. All right, so our estimation 180 question today was provided to us by Lucille, and her question is, how many red vines are left in this Costco tub? Again, how many red vines are left in this Costco tub? All right, thanks again, Lucille, for that estimation 180 question. So the quarantine challenge of the question number 4 was the question called Someday Soon, and there was 2 parts to the question. The first part was when is the last someday, and then how many somedays are there? And so the first part, the answer is if you think about the 2 biggest, the biggest month and then the biggest day, that would be December, and the last day in December is 31. So 12 plus 31 is 43. And so the last someday would be December 31st, 2043. So that is the last someday. And then the part 2 is actually a little simpler than you might think. The correct answer is 365 because each day has a standard, it's part of a someday for some year. And so there are 365 days. Now you might think, what about the leap year? But the leap year is actually what is it called? Sorry, uh, um, February 2nd, which would be sorry, February 29th, which would be 31. But 2031 isn't actually a leap year, so the answer is 365. And the people that got that right, there was 4 people that got that right. It was Audrey P. Nice job, Audrey P. Mateo, nice job, Mateo. Oliver, nice job, Oliver, and Vance. So that's Audrey, Mateo, Oliver, and Vance. So the 4 of you, really nice job. All right, so I know that I gave you guys a lot of worksheets on the last math exploration, but from all the work that I've seen, it really seemed like you guys really grasped the angles, classifying triangles, perpendicular lines, line symmetry, intersecting lines, all that stuff. So really, really great job on that. So I know that it was a lot, but it seemed like you guys really understood it. So that's fantastic. So I'm not really going to do any observations because it seemed really, really great. So for this math exploration, we're going to go over ordered pairs. I'm going to do that, and then we're going to look at a pattern and then create a graph with that pattern. And then we're going to do some classifying of quadrilaterals with a little bit of review of classifying triangles. And again, I'm going to change the orientation of the camera so that you can see the piece of paper in front of you. All right, so we're going to learn about ordered pairs. And we're going to do that by, I'm going to place a ordered pair, a little dot here. And an ordered pair allows us to be precise about where a point is in a graph. And the first thing that you do is that you find out what column it's in. So it's in column 2 and it's in row 3. And so because it's in a very specific order, it's called an ordered pair. And so the ordered pair of this blue dot is at 2, because it's in column 2, row 3. So that's 2, 3. Now I'm going to play a game against myself where I'm trying to get 4 coordinates in a row. And I'm going to put this in today's work as an optional game that you can play with your family if you want. It's very similar to Battleship. So if you play Battleship, you know coordinate ordered pairs pretty well. So the point of the game would be to get 4 in a row, either vertically, horizontally, or diagonally. So let's say I go here. Think about what ordered pair that would be. Remember, first columns first, and then rows. This is column 4, row 1. So this would be 4, 1. So now it's blue's turn. I'm going to go here. And again, this would be column 3, row 4. So this is 3, 4. And I'm going to blue here. And again, this is column 1, row 2. So this would be 1, 2. And I'm going to go here. And this is column 5, row 6. And I'm going to go here. Now, there's a special name for this one. This is the origin, and this one's at column 0, row 0. So this is at 0, 0. And then this would be column 4, row 5. And I won since I got 4 in a row. So again, if you want to play this game with your family, it's going to be in the email, and I'm going to also put it on Schoology. Again, this is not a mandatory game, so if you want to do this, you can. All right, so next up, we're going to look at a pattern of blocks here. So this first pattern, and we're going to hopefully be able to graph a pattern here, so to help us kind of make some observations about the pattern. So here we have 2 blocks. So that's the first sequence in our pattern. Then our second arrangement is this one. And then our third arrangement is this one. You might already be making some observations about what the pattern is here. And the next arrangement. And then finally, our last arrangement looks like this. And so you might already be thinking about, how does it change from each one? So in order to really make that really, really visible, I have this worksheet here, and we're going to be graphing this cube sequence. Now, this first one, it says, the picture below shows the first 5 arrangements in the cube sequence we've been working with this session. Record the number of cubes it takes to build each arrangement. So it took 2 cubes to build that first arrangement. Then you might have noticed that there was a layer of 4 from that 2. So 2 plus 4 was 6. Then the next one, it was the 6 plus another 4. So that's 10. Then we had that same arrangement, but then we added 4 in the bottom, so that's 14. And then again, we added another 4 in the bottom to make 18. So interesting pattern there already. So it says, write an ordered pair to represent each cube arrangement. Use the arrangement number for the first number in the pair and the number of cubes in it that makes the arrangement for the second number in the pair. So for example, arrangement 1 would be written as 1, 2, and arrangement 2 would be written as 2, 6. So this is the first arrangement and there are 2 cubes in that arrangement. Arrangement 2 is second arrangement, and it has 6 blocks in it. This is the third arrangement, and it has 10 blocks in it. Arrangement 4 has 14, and arrangement 5 has 18. Now, this is where ordered pairs and graphing comes in. And so we have our ordered pairs, and this side we've decided is the arrangement of cubes. And I'm going to make sure you can see that. This bottom side is the arrangement of cubes. And then this side is a number of cubes. So in arrangement 1, there was 2 of them. So I go to 1. And as you can see here, this is going up by 2s. So you do have to be careful. You can change it to what you want. But right now it's telling me that I'm going by 2. So the first one would be here. So that is ordered pair 1, 2. Then I go to the second arrangement. That's 2. And I go up to 6. Third arrangement, I go up to 10. The fourth arrangement, I go up to 14. And then the fifth one, I go up to 18. Now, this pattern isn't too complicated. I'm sure most of you notice that I'm adding 4 each time. But what happens with this graph is that you can actually make a prediction. You can see it visually of where this will continue. I can actually draw a straight line here. And I get a ruler. Or maybe not. I'm going to use this book instead. And if I were to draw a line, this line would fit all the rest of the pattern forever. So that's one of the things that ordered pairs can help us with, is able to see what patterns there could be with ordered pairs and graphing. So it's actually really, really cool. So there's going to be a worksheet that's going to be very similar to this in your work today. All right, so if you remember last week, we talked about triangles, but I didn't introduce a word called hierarchy. And a hierarchy is a way of classifying objects, and in this case, shapes, that starts with a really general term, and then you get more and more specific within that classification. So we're going to look at triangles first. And one thing to remember is that all triangles are polygons. And triangles are a very specific type of polygon that has 3 sides. We know other polygons like quadrilaterals have 4 sides, pentagons have 5, hexagons have 6, and so on and so forth. So we're going to stay with triangles here. So from polygons, this is probably the most generic term. We're going to go to triangles. And this is just based on the number of sides. Number of sides. So because it has 3 sides, it's called a triangle. But that's like first grade kindergarten stuff, right? So the next level of hierarchy is the length of the sides, the side length. So we have side length. So we have very specific names for triangles based on the side length. So there are equilateral triangles. And that's where all the sides are exactly the same. We have isosceles triangles. And that's where 2 of the sides are the same length. And then we have scalene. And that's where none of the sides are the same. So we went from polygons in their hierarchy, polygons, to if it has 3 sides, it's called a triangle. And if that triangle has all the sides are the same length, it's called an equilateral triangle. If 2 of the sides are the same length, it's an isosceles triangle. And if none of the sides are the same, then it's a scalene triangle. But again, we can be even more specific here. So the next part would be the angle size. Now, the interesting thing about an equilateral triangle, because all the sides are the same, this will all the angles in an equilateral triangle will always be acute. So we actually just leave it as equilateral triangle. Now, isosceles triangles, on the other hand, they can be different. So if one of the angles is obtuse, then it is an obtuse isosceles triangle. So you want to be really specific. And if one of the angles is right, then it is a right isosceles triangle. And if all of the angles are acute, then it is an acute isosceles triangle. Now, same thing for scalene. For scalene, if one of the angles is obtuse, then it is an obtuse scalene triangle. If one of the angles is right, then it is a right scalene triangle. And finally, if all of the angles are acute, then it is an acute scalene triangle. So this is a really great example of hierarchy, right? These are all polygons. They have 3 sides, so they're called triangles. And then we talked about their side length, and then we can even be more specific based on their angle size. So we're going to move now to quadrilaterals. And here we have our quadrilaterals, quadrilateral hierarchy. And any polygon with 4 sides is called a quadrilateral. And so here is the hierarchy of quadrilateral, right? That's the most specific here. Now, for this one, it says a quadrilateral with exactly 1 pair of parallel sides. So it just has 1 side, 2 sides that are exactly the same, and that would be a trapezoid. A quadrilateral with 2 pairs of parallel sides opposite each other, and this is called a parallelogram. A quadrilateral with 2 pairs of adjacent sides that are congruent. And congruent means that they are the same length. And this is a kite. So an example of this would be, let's say that those 2 are the same length. And those 2 are the same length. And so this would be a kite. So it has 4 sides. These 2 are the same length, and these 2 are the same length. A parallelogram with 4 right angles is a rectangle. You might be thinking, wait, a square has that too, but this definition doesn't say that all the sides are the same. A parallelogram or kite with 4 congruent sides. So all the sides are the same. Now that's close, but doesn't have the right angle. So that's a rhombus. And finally, a parallelogram or kite with 4 right angles and 4 congruent sides. That, in fact, is a square. All right, so I can't imagine that any of that would be too confusing for you. Maybe the hierarchies of quadrilaterals might be a little tricky, but I'm hoping that with the worksheet that you'll be able to practice some of this. So I'm going to actually share so you can see the worksheet here. So the first thing here, this is the first page of the worksheet, and it'll be some coordinate dot to dots. And so you'll be practicing your ordered pairs, and so this will make a picture here. The second one is very similar to what we did with the graphing sequence, but you have a different set of blocks. One thing to know is that we're assuming that these blocks have 4 underneath it. So just be aware of that. So you'll get a chance to graph that. And then some more practice with some triangles. It does say here that you're doing it, you should do it with your geoboard first. Obviously you don't have geoboards. So I would just practice here and then you can erase. And then the last 2 pages are the quadrilaterals. And so this should look very familiar to what I did. So if you need to go back and look at the video again, I would highly recommend that because it looks very similar to this, because all the questions that you're going to be answering are based off of this hierarchy of quadrilaterals. And so just be wary about that you should be looking at all of this. And so That'll be due this Thursday at by the end of the day, so that I can look at all your work and then make a new video on Friday. So I think that you should be able to do all this, and good luck. All right, so I'm going to introduce a new coloring sheet mural for today. It is a Deadpool coloring sheet, and so it looks like this. So that's the Deadpool on a Nyan cat. So I'm hoping that that will be silly enough for you guys. And then the next thing I'm going to talk about is the quarantine challenge question number 5. And so here's what it says. It's called The Usual Suspects. 4 men are taken to police headquarters following a bank robbery. The police are certain that one of them is guilty, but they don't know for sure which one did it. Here's what the 4 men had to say for themselves. Alan said, Bill did it. Bill, Don did it. Charlie, I didn't do it. Don, Bill lied when he said I did it. If only one of the 4 statements is true, who is the guilty man? So that'll be due on, let me make sure here, May 5th. That's next Tuesday, May 5th at noon. So make sure to turn that in. And then lastly, it's a goodbye message. And this goodbye message is to let you guys know that if there's any questions about any of the math, or you just want to be able to talk to me, have your parents shoot me an email, or you can send me a message through Schoology, and I'd be more than happy to have a one-on-one conversation with you. I had one with a student yesterday. It was really quick. They asked a question about some of the math, and I was able to answer their question. And if you have that, please don't hesitate to reach out. I'd be more than happy to talk to you and ease anything that you might be wondering about or worried about. It doesn't have to be math related, but it totally can be math related if you want. But I just want to open myself up to know that if you have any questions, or if you're stuck, or if your parents are stuck, or you're not sure, or somebody is not sure, please reach out to me. I'd be more than happy to talk to you. And we'll set up a video conference, or we can talk on the phone. And then an extra credit assignment that I want to give to you is, this is just purely silliness, but we've done 11 of these episodes now, and I'm sure I've made a lot of funny faces. And so if you want to go back to any of the videos in the past and do a screenshot of my face and then send them to me, you can draw on it if you want, and then I'll do a gallery of some of your favorite pictures, screen grabs of me during these episodes. So if I make a silly face, or you just find something that I did was really funny, take a picture of it. You can screenshot it on your computer and then send that to me, and then I'll have a little thing at the end in the next episode. So lastly, here is the answer to Lucille's estimation 180 question, and I'll see you next time. Goodbye.